Hi, my name is Dr. Tom Berkness. I am the Director of Clinical Pharmacy for National Pharmacy. Today, I'm going to talk a bit about COVID-19 vaccines, what's available in Canada, how they work, and go over some important questions that people may have. So these are the currently available vaccines for the SARS-CoV-2 virus that are available to us. The first two are both what are known as mRNA vaccines. The first that was available is the Pfizer vaccine, and the second one was the Moderna vaccine. mRNA vaccines can be made a little bit quicker than other vaccines, and that's why they were the first two. The next two is the AstraZeneca vaccine, which came out third. That was available at the end of February. It's a viral vector vaccine. And the most recently made available vaccine is by Janssen, and that also is a viral vector vaccine. So let's talk a little bit about how vaccines work. First of all, the picture we have here is of a SARS-CoV-2 virus particle. As you can see, it's got a lot of these little red bumps on it. Those are called spike proteins. The spike protein on the virus is what allows it to attach to our cells and get into the cell. Those spike proteins are actually the target for our vaccines. So when the virus enters our body is going to recognize that spike protein and is going to have an immune response to it. So how do vaccines really work? Well, what a vaccine does is it stimulates an antibody-mediated immune response. So the body recognizes proteins that are foreign, that aren't normal. And when it recognizes those proteins, it has an immune response. If the body has seen that protein before, it usually has a stronger immune response. So what happens with vaccines is they're a way of showing the body a protein that is related to the virus so that the virus can develop this immune response so that the next time the body sees the virus or the protein from that virus, when the virus actually infects you, it has a much stronger immune response and can fight off that virus so that you don't get sick. So how does that work? Well, the mRNA vaccines take a piece of the virus from the SARS-CoV-2, a piece of messenger RNA, which is actually called messenger ribonucleic acid, which you probably realize sounds a lot like DNA, deoxyribonucleic acid. Messenger RNA is a single-stranded piece of DNA that's basically instructions for making a protein. So they take the messenger RNA out of the virus, and they put it into something called a lipid nanoparticle. That's just a particle that we use to put it into the body. So that mRNA is injected into the body in these lipid nanoparticles. And then that mRNA goes into cells. And when it gets into the cells, it tells the cell to start making these spike proteins. So our body's making the spike proteins, which our body then recognizes as being foreign and makes an immune response to them. And then the mRNA gets broken down and destroyed. So now we have this foreign spike protein in our body. Our body recognizes it, develops an immune response, and the next time we see that spike protein, probably when we get infected with the virus, we're going to have a nice strong immune response and we're going to kill that virus. So that's how the messenger RNA vaccines work. The viral vector vaccines are pretty similar in that they also stimulate an immune response to the spike protein. They're a little bit different because instead of using just the RNA in a lipid particle, what they do is they take another virus, in this case, an adenovirus, which is the type of virus that commonly causes the cold. They take the genes from that virus that makes it replicate, and instead they put in the gene that makes the spike protein. So now we have an adenovirus or cold virus that can't replicate and make you sick, but it can produce a spike protein. So we put that virus in the vaccine, we put it into your body, the body starts making those spike proteins and they get recognized as being foreign and we get the immune response. And then once again, just like before with the mRNA vaccines, when you get infected, the body sees those spike proteins, recognizes them and says, hey, we can have a good immune response here, and goes and kills the virus. So that's how the vector vaccines work. They use a viral vector, in this case, adenovirus, to put the protein, the spike protein, into the body. What's really, really important here to realize is that both the mRNA vaccine and the viral vector vaccines cannot actually cause an infection. So you can't get an infection by just getting the vaccines. So there's no way that you can actually get infected with COVID-19 just from getting the vaccine. Okay, let's look a little bit more specifically at the individual vaccines. First, the Pfizer vaccine. That is a 2-dose vaccine. So the regimen to use it is 2 doses. The first dose and then the next dose at 21 days is how it originally came out. But as of the beginning of March, Health Canada approved it for being up to 16 weeks apart between the first dose and the second dose. Most of the studies used anywhere from 19 to 42 days. The Moderna vaccine is also a 2-dose regimen. You take your first dose and then about a month later, the second dose. AstraZeneca, the first viral vector vaccine, is also a 2-dose vaccine, and you can get that second dose anywhere between 4 and 12 weeks. And finally, the Janssen vaccine is a 1-dose dosing regimen, which is great because obviously all the logistics of trying to arrange when you get your second dose and having it available, etc., are gone. I have in brackets Johnson & Johnson. That's because Janssen is part of the Johnson & Johnson group. So you may hear the Janssen vaccine referred to as the Johnson & Johnson or J&J vaccine. What the Health Canada has said so far is that all regimens should be completed with the same vaccine they were started with. So in other words, if you get your first dose of a Pfizer vaccine, the second dose you get should also be the Pfizer vaccine. The same, of course, goes for Moderna and AstraZeneca. They've also said only in the rarest of circumstances can the second dose be a different vaccine? And if it is going to be a different vaccine, it should be the same type. In other words, if the first vaccine you got was an mRNA vaccine, the second dose should also be an mRNA vaccine. So if there just isn't any Pfizer vaccine available, and that's what you got the first time, then use the Moderna one for the second dose, not a viral vector vaccine. But that's, again, only in the most extreme circumstances. What we really want to do is make sure we have the same vaccine for both doses. The other important point I have down here is that Health Canada has also said we have to wait 14 days after giving any vaccine before we give a COVID vaccine. So if you've had influenza vaccine, for instance, you have to wait 2 weeks before you get the COVID vaccine. And on the other end of the spectrum, once you've had the COVID vaccine, you must wait 28 days before getting another vaccine. And because these vaccines are quite new, the reason for this is that we don't want reactions to other vaccines to be seen as reactions to the COVID-19 vaccines. Okay, some other important points about these vaccines. Firstly, I'm sure we've all heard about this. The Pfizer vaccine needs to be kept frozen at a very, very cold temperature, minus 70 degrees Celsius. The Moderna vaccine also has to be kept frozen, but not quite as cold. The reason for that is the lipid nanoparticle that the mRNA gets put into can break down pretty easily. So it has to be frozen. Otherwise, it might break down and then the vaccine wouldn't work. So obviously, minus 17 is really cold, and you have to have special freezers for that. So typically, when the Pfizer vaccine is given, it's given in a special facility that has those freezers available. The Moderna vaccine is a little bit easier because normal freezers can be used. They don't have to go down to -70. Much easier still is the AstraZeneca and the Janssen vaccine, the viral vector vaccines. They can be stored between 2 and 8 degrees Celsius. So transporting them is a lot easier. Storing them is a lot easier. We don't have a lot of the logistical problems that we do with the first two vaccines. So let's talk a little bit about vaccine efficacy. How well does a vaccine prevent disease? What I'm showing you here as an example is from the AstraZeneca vaccine, and that's on purpose because there's been a lot of discussion about the fact that the efficacy of the AstraZeneca vaccine and the Janssen vaccine is not nearly as high as the two mRNA vaccines, Pfizer and Moderna. So from the studies of the AstraZeneca vaccine, I've broken this down for you in terms of the size of the group, the number of people who got a placebo dose, about 4,400, and the number of people that got a vaccine, again, about the same amount of people. The number of people who got COVID in each group, well, in the placebo group, there were 71 people who got COVID-19 infection. And in the vaccine group, there were 27 people who got the COVID-19 vaccine. Now, if you look at these numbers here, and you take 71 minus 27, the number of people who were infected, get 44. You divide that by the number of people in the placebo group, multiply by 100, you get 62%. So what we hear is that this vaccine is 62% effective, which basically means that's how much better it is at preventing illness compared to placebo. But what's really important is the percent of people who got infected. So in a group of people who weren't vaccinated, they had the placebo, 1.6% got infected. In the vaccine group, 0.6% of people get infected. So if you get this vaccine, you only have a 0.6% chance of getting infected, which is obviously very good and a lot better than if you think that 62% means there's a 38% chance you'll get infected. That's not the case. There's only a 0.6% chance you'll get infected. What's really important here is also these two facts. The number of infected people in the vaccine group that needed to be hospitalized was 0. And the number of people who were infected in the vaccine group that actually died was also 0. So what we know is that the vaccine is good at preventing the infection. And even if you get the COVID-19 infection, the chances are it's going to be quite mild. It won't make you sick enough to be hospitalized, and it certainly won't make you sick enough to die. So this vaccine, even though it's only 62% effective, it still is very effective in that people don't get hospitalized and they don't die. So let's look at the 4 different vaccines and their efficacy then. The first two, the mRNA vaccines, are really good at preventing any kind of disease, 95%, 94%. And frankly, such huge high numbers are really a big surprise. Nobody expected them to do that well. So they're really, really good at preventing disease. The AstraZeneca and the Janssen vaccine are very similar to each other in that they prevent about mid-60s, 62% and 66% in terms of preventing infection. But remember, that translates to being a very small number of people that get infected. And importantly, for both of those vaccines, they can prevent severe disease and they can prevent death. So it's really not a case of, oh, we should only use the first two because they're more effective. No, all of these vaccines are very good at preventing hospitalization and death. So, if you have a chance to get a vaccine that will prevent you from getting very sick, being hospitalized, or dying, you would take it. And if that's what's available, then, take it because it's good for you. I've also put down the number of people over 65, the efficacy in people over 65, because that's an important age group. Certainly in the the people that we deal with at National Pharmacy, retirement homes, and long-term care facilities, they tend to be older. So the Pfizer vaccine does have information in people greater than 65 in it. It's about the same amount effective there. Moderna is very close as well. So again, very high. For the other two, the information is there's not enough people over 65 to break it down, but people over 65 are included in those 62 and 66% numbers. If we look at the safety and efficacy of the mRNA vaccines, we also have information in people who were pregnant when they got the vaccine, in people who were immunocompromised, or people who had previous COVID-19 infection. And we know that it works in those people as well. So that's very important. So let's talk a little bit about side effects, because that's obviously something that people are concerned about. So a vaccine causes an immune response, and immune responses have symptoms. So when you get a cold or infected with influenza or something, you get symptoms from it. You don't feel well, you get fever, muscle aches and pains, chills, fatigue, etc. And a lot of those symptoms are because your body is having an immune response to the virus that's infecting it. So not surprisingly, when you give a vaccine and create an immune response, you may get some of those side effects. So at the injection site, it's pretty common to get some pain where the vaccine is injected. 80% of people tend to get injection at the site of the pain at the site of injection with the mRNA vaccines. And that's probably because the mRNA is infecting cells right at that site. And you can get some local swelling and tenderness in the axilla, and that basically means armpit, the axilla. So you can get some swelling and tenderness in the armpit on the side of the body where the vaccine was injected. Other side effects, more general systemic side effects, like we already said, fever, fatigue, muscle pain, chills, headache, joint pain. So if you get a vaccine and you start getting some of those side effects, typically they're not very bad. They only last for a few days. And really what it means is the vaccine is working and it's causing an immune response. So let's talk a little bit about some of the questions that people have about these vaccines. The first one, and it's an important one, is how long does the immunity that you get from COVID-19 vaccines last? Well, so far, we don't really know how long it lasts. People who were studied with vaccines are still being followed to see if their immunity starts to wane. So we know that it certainly lasts for several months because the vaccine started being tested in this past summer in 2020. So we know that lasts several months. What's going to happen in the future? Well, that's hard to say, but people will keep being followed and keep being tested, and we'll see if the immunity starts to wane. Do I need to get 2 doses? Well, for the Moderna and Pfizer and also the AstraZeneca vaccine, they were studied with a 2-dose regimen. So yes, you do need to get 2 doses, although the first dose does give you some immunity. The second dose is the one that really increases that immunity dramatically up to those 94, 95% range. Of course, the Janssen vaccine, which again is a subsidiary of Johnson & Johnson, that vaccine is only a 1-dose regimen. So no, you don't have to get a second dose of that. If immunity starts to wane, will you need to get a booster dose at a later time? That's also a very good question, and we're not so sure. If immunity starts to wane, it might make sense to get a booster dose the same way we do with other vaccines so that you improve your immune response. Are COVID-19 variants covered? Well, so far the answer is yes. There are some studies using different vaccines in different places where the efficacy was less in one place than another. And it's theorized that the reason for that is that there are more variants in the second place and the vaccine didn't work as well in those. But what we know right now is that yes, The variants that we're seeing are covered. So getting the vaccine is still important. Will variants come up in the future that might not be covered by the vaccine? It's possible. But remember, it's only the one protein, the spike protein that the body recognizes on the virus. And a variant, variations can change in any of the proteins on the virus. So it has to be very specifically a protein on the spike protein that has to change, and it has to change enough that the body wouldn't recognize that protein. And if the virus changes enough that the spike protein isn't affected, it might change in other ways, like becoming less virulent. So it might not cause as bad infection. So we don't really know what's going to happen with variants. What we know right now is that they are covered, and the best way to get out of this pandemic is to get vaccinated. Okay, a few more questions here. Can I get the vaccine if I have a latex allergy or food or insect allergy? So the answer there is yes. You can get the vaccine if you have any of those allergies. One of the things that we used to talk about and worry about a lot was people with egg allergies. And that's because egg media was used to grow vaccines, but it's not anymore. So that's not really an issue. There is a 15-minute waiting period after vaccination. So after you get your dose, you sit and wait for 15 minutes just to make sure you're fine and no reactions occur. And places that give the vaccine are required to be able to treat reactions if they happen. So they have the appropriate medications and training, et cetera, to be able to deal with that. If you've had a severe reaction to a vaccine in the past, you can still get a vaccine, but you have to wait for twice as long. You wait for 30 minutes to make sure you're fine before you leave. Can pregnant women get the vaccine? I think I already mentioned this. Yes, they can. Why? Because these vaccines are only using a small amount of material from the virus. There's actually no live virus in the vaccine, so it can't make pregnant women, or it can't infect the fetuses of those women. So yes, pregnant women can get the vaccine. Well, another big group, obviously, is children, and I believe children make up something like 18% of the Canadian population. So getting kids vaccinated is going to be important to get to herd immunity. So can children get vaccinated? Well, right now, the Pfizer vaccine was only studied in people 16 and older, and then Moderna, AstraZeneca, and the Janssen vaccine in people 18 and older. So they're only approved for use in adults. The AstraZeneca vaccine is being studied right now in kids as young as 6 years old. And other studies are going on with the other vaccines as well. So hopefully we'll get approval for kids getting younger and younger to get the COVID-19 vaccine. We know that kids don't seem to get as sick when they get infected, but they can carry the vaccine and transmit it to other people. So it will be important to get them vaccinated in the future as well. This is a really good question, and people, I think, who are a little bit hesitant to get the vaccine ask this question a lot. How did it get done so quickly? How did they make these vaccines so quickly? Did they skip steps? Is it not safe? I've had one person say to me a number of times, that they didn't even study these in animals before they gave them to humans. So let's talk a little bit about some of those issues. First of all, they don't give vaccines to animals, so that was never really an issue. They don't test them in animals. There are vaccines for animals, but they don't test them that way. But within 1 month of the first cases of COVID-19 being recognized in China, scientists had already fully elucidated the genomic structure of the SARS-CoV-2 virus. In other words, when they realized that this virus was out there causing these infections, people started looking at the virus and figured out the DNA structure, how the virus was coded right near the beginning, within a month of the first cases. So that meant that they could start looking at the RNA that coded for different proteins in that virus and start making vaccines very quickly. One of the other important issues is that mRNA vaccines can be developed a little more quickly than other vaccines, because what they're doing is taking the mRNA from the virus, giving it to you, and then letting your body make the protein that your body recognizes and makes an immune response to. In more traditional development of vaccines, making those proteins is done outside the body. So there's an extra step in learning about how to make the vaccine and producing the vaccine, where you have to actually produce that protein before you put it into the body. mRNA uses your body to make the protein, so it's a little bit quicker. It takes out that process of figuring out how to make the vaccine and producing it. One of the other important steps was that the development of these vaccines were actually done simultaneously rather than just one after the other. So, for instance, they started doing safety studies, and they started getting good numbers in the safety studies. And before those studies ended, they started doing efficacy studies, so that those steps were overlapped, which meant the overall time was cut down. And importantly, they also started looking at how to manufacture the vaccine, how to scale up that manufacture so that they could produce large numbers of vaccines quickly, and also started fitting factories and laboratories with the equipment so that they can make those vaccines very quickly. So a lot of that stuff was done at the same time rather than just one after the other, so that the total time to produce the vaccine was significantly shortened. Normally, you wouldn't want to do that, because if something goes wrong and you can't sell your vaccine, you lose a lot of money. But in this case, it was so important to get the vaccine done as quickly as possible. Those things were done in an overlapping manner. Health Canada and other health agencies around the world also helped out by doing what's called a rolling review of data, which means they didn't say you have to do everything. Show us how you put it together, show us the studies, show us how, whether it was safe, then show us the studies of how well it works, etc. They didn't say you have to do all of that and then give it to us and we'll look at it. They said, as you get information, give it to us and we'll look at it as we go, so that by the time everything is done and we know it works, we'll already have looked at all the data and the final review will be very fast. So Health Canada helped out by cutting down the amount of time that it takes to review all of the information before they approve something, by allowing this rolling review of data. So the important takeaway here is that there were no corners cut in making or approving the vaccines. In other words, everything was done like it was supposed to be done, tested appropriately, and all the checks and balances in terms of ensuring that the vaccines are safe and effective before they are approved by Health Canada. All of that was done just like it would be. It was just done in a different way to make the time it took a lot less. So no corners were cut, and all the vaccines that came out and got approved by Health Canada have been shown to be safe and effective. So that's really all I wanted to say about the COVID-19 vaccines. I hope this has been educational and people will benefit from it. Any other questions, please feel free to contact National Pharmacy. Myself or others will be happy to help you.